Section 4.6 is on operations with complex numbers. First of all, we talk about the imaginary unit, which is an I. That allows you to solve equations like x squared equals -1, because typically when you square anything, you should get a positive answer. So we define if r is a positive number, then the square root of -r is I square root r. And I square root r squared is -r. Better put, the square root of -1 is I. Okay? So if you think about when you were coming up here, if I were to solve this equation, if I were to take the square root of both sides, I would have an answer of plus or minus the square root of -1, and that's going to be I. That's where the imaginary unit came from. So if you ever see I squared, okay, let's think about if I were to square the square root of -1, I is the square root of -1, so if I were to square that, the square root and the squared cancel each other out and it would be -1. Okay, so I is the square root of -1. If you ever see I squared, you should change that to -1. Let's solve. First, I want to solve for x, so I'm going to subtract 26 just like I typically would in any other equation. So I've got 2x squared equals -36. Now we're going to divide both sides by 2. X squared equals -18. Now we need to, in order to solve for x, we need to take the square root of both sides of the equation. Square root and squared cancel each other out, leaving me with x. And remember, we put this square root in here, so I need a plus or minus, very important. Now let's think of square root -18. I'm going to split that up into 3 things. First, I'm going to split that up into -1. That's going to take care of this negative. And then 18 would be 9 times 2. Okay, so this still equals -18 inside the square root. So if I'm going to simplify this, we've got plus or minus. This -1, square root -1, remember we just talked about, is I. Now notice I'm leaving some room after the plus or minus because I also need the square root of 9, which is 3. And typically we write the number in front of the variable or the imaginary unit I. So it'll be plus or minus 3I, and then we still have square root 2 hanging out at the end. And I can't simplify that any further, so I would just keep that as square root 2. So that would be my answer for solving that equation. Another problem. First, I would start out by getting rid of this -1/2. We could divide by -1/2, but that's the same as multiplying by its reciprocal, which is -2. So I'm going to multiply both sides of this equation by -2. When I do that, the -2 and the -1/2 factor each other out. That leaves me with x plus 2 squared equals -10. Now again, when I have something squared, I can take the square root of both sides so that the square root and the squared cancel each other out, leaving me with just this x plus 2. Now we have equals, and if I put this square root in, I have to have a plus or minus. Okay, now you can think of this a couple different ways. We can think of this as -1 times 10 inside the square root, or you can get into the habit of anytime you have the square root of a negative, just put an I out in front of the square root. That gets rid of this negative. So that leaves me with I square root 10. Can you simplify the square root of 10 any further? There are no perfect squares other than 1 that go into 10, so that would be simplified completely. But now I need to solve for x, so I have to subtract 2 from both sides. So I have x equals. Now, just like we did with the equations without the complex number with the I, I always put this -2 first, then the plus or minus I square root 10. It looks a little bit less confusing. Plus, it doesn't look like -2 is underneath the square root. Okay, so we'll keep this in the front. Plus, we're also going to talk about in just a moment how complex numbers are written with the real part first, plus or minus the imaginary part is always second. So this would be also the standard form of a complex number. This actually talks about complex numbers. They are written in standard form if the number is a plus bi. A and b are both real numbers. But realize that number a is the real part because it does not have an imaginary I unit connected to it. So bi is the imaginary part. Now, if I were to add or subtract these two complex numbers, really all I'm doing is combining like terms, which means I take the two real parts, add those together. -1 plus 3 is 2. Put the imaginary parts together. Plus 2i plus 3i is plus 5i. So it's really just like combining like terms. That's all you have to do for that. Now, the only thing that's different over here, notice we have this minus sign here. And remember when we talked about subtracting is the same thing as adding the opposite. So all the signs in the parentheses right after the minus sign have to change. So this becomes +2 and then -9i. Now it's just a matter of combining the real parts. 6 plus -8 is -2. Plus 2 is 0. So I actually have 0 for the real part. Now we combine the imaginaries. 4i plus -9i is -5i. You can also write this as -5i. That is still written as a complex number. It's just that the real part is 0. Now let's multiply. First we start with 3i times 9, that's 27i. Then we take 3i times -i is -3i squared. Where it's different, if you remember way back in the beginning when we went through some definitions, I squared is also known as -1. So anytime you see I squared, you should replace that with -1. So I would rewrite this 27i minus 3 times -1, which is 27i. -3 times -1 becomes +3. Okay, so far we've put this all together. We changed I squared to -1 and simplified that. Now to write this as a complex number, the real part should go first, so it should be 3 plus 27i. That would be my final answer in complex number form. Now, next problem would be FOIL. -1 times 3 is -3. -1 times -6i would be plus 6i. 4i times 3 is plus 12i. And then 4i times -6i is minus 24i squared. And again, we need to replace this I squared with -1. Now, if you think about it, what this is really doing, if I were to put a -1 in there, it would be -24 times -1. So what I usually get into the habit of doing is I get rid of this I squared and make this number positive or opposite sign. So now it's a matter of combining the like terms. To start with, I'm just going to rewrite this. -3 plus 6i plus 12i plus 24. Now to combine like terms, -3 plus 24, those are the real parts, that's 21. And then the imaginary parts, positive 6i plus 12i is plus 18i. So I have the real part plus the imaginary part. That is written as a complex number. The complex conjugate of a plus bi is a minus bi. we talked about conjugates before when we talked about radicals. Now, if you think about I, that is the square root of -1. Remember, we can't have radicals in the denominator, so I actually need to get rid of this I down here in the denominator. If all you have is an I down here, you know what, let me say it this way. If I had 4I, that's really 0 plus 4I. If you think about putting the real part in front of that. So now if I want to multiply this by the complex conjugate, it would be 0 minus 4I, which is really just -4I. So I'm going to multiply the denominator by the complex conjugate, which is -4I, but that means I also need to do that to the numerator. So we're going to multiply top and bottom by -4I. I'm just going to get rid of that just to make it less confusing. So now when I multiply out, we distribute on the top, so it'd be -8I, and then positive plus 12I squared over 4I times -4I is -16I squared. And again, like I told you before, what I usually do, since I squared is -1, I cross that out and make this number in front of it the opposite, so that becomes -12. Cross the I squared out and make the 16 positive. I'm going to write the real part first, so it'd be -12, okay, because this now becomes real, -12 minus 8I over positive 16. Now to finish this up, to put this in true complex number form, I actually need to write this as two separate fractions. And if you remember, we actually did this a long time ago, like back in chapter 1 or 2. First, I would take these two and simplify that fraction. What goes into 12 and 16? 4. So it would be -3 over 4. Okay. Then we also have to take these two, and that makes a heart. So if I ever say the heart thing, you'll know what I'm talking about. And we've got negative over positive, so it's still going to be minus. And then 8 over 16 is 1/2 I. Okay? -3/4 minus 1/2 I. So now that is the final answer written in complex number form. One more, just to make sure we understand complex conjugate. If I want to get rid of that I in the denominator, I would multiply top and bottom by 1 plus 2I. We're just changing that middle sign when we do our multiplication. Okay? And then when we do this, if I FOIL this out, it's going to be 3 plus 6I plus 11I plus 22I squared all over 1. And then again, our whole reason for doing this is that the outside and the inside are going to cancel out. And then when I multiply the last two, it's going to be minus 4I squared. Okay? And again, to get rid of these I squareds, cross those out, make this a -22, cross that out, make that a +4. If it helps you, you can just go ahead and replace those with -1. You'll see that it just changes the sign. Now, let's put these together. 3 plus -22 is -19. Combine the i's, it'd be plus 17I, all over 1 plus 4 is 5. Now, to write this in simplest form, I'm going to take these two over each other, so it'd be -19/5. And then I take these two over each other, and it's going to be positive 17/5 I. So that would be my final answer written in complex number form. And that now concludes section 4.6.